We began this module by discussing the purpose of networks. How can a network benefit us? And just a couple of examples, we said that we could surf the web thanks to our computer networks. We could share files or printers within an office over a computer network. And then we started to get into some of the pieces and parts that make up a network. We had components such as routers and switches. We talked about the media that we could use to interconnect those components. And as we're delving into network technologies, we need to understand some terminology that describes the type of network we're dealing with. There are different ways of categorizing networks. We saw that we could categorize networks by topology, for example, ring or star or bus. We saw that we could categorize a network by how geographically dispersed the network components were, like a LAN being local and a WAN being a wide area network. And we saw that we could even categorize networks based on where the resources being shared were located. We contrasted a client-server network with a peer-to-peer network. In this module, we considered a couple of different models that network designers, network administrators could use to take a technology or a protocol or a piece of networking equipment and see how it interoperates, see how it relates with another piece of networking equipment or a protocol or a technology. That was possible by having these standardized reference models that different industry professionals could use. For example, the ISO, the International Standards Organization, developed the 7-layer OSI, the Open Systems Interconnect model. And we talked about the 7 layers, and we gave you a couple of acrostics for remembering those 7 layers. All people seem to need data processing. That was top-down, application, presentation, session, transport, network, data link, and physical. Or please do not throw sausage pizza away, going from the bottom up. And we talked about the function and the purpose in life for those 7 layers. One of the drawbacks, though, to the OSI model was that it was developed back in the day where it was more than just IP on the network. We might have AppleTalk or DECnet or IPX or a variety of other protocols out there. But today, it's mainly IP. Maybe IP version 4, maybe IP version 6, maybe both, but it's primarily IP on our networks today. So instead of having a more generalized reference model like the OSI model, some people prefer to go with the TCP/IP stack, also known as the DoD, the Department of Defense model. And this only had 4 layers. It was much easier to identify a protocol and say, oh, you go at the application layer. We would have to know a lot of details about that protocol to plug it neatly into the OSI model perhaps, but with the TCP/IP stack, we could say, well, I know this is an upper layer protocol. I know it's encapsulated inside of TCP, therefore, I'm going to stick it at the application layer. And another big advantage, of course, from learning these different models is, as you go throughout your networking career and you're reading different documentation, different reference material, you're going to see references to these layers. So if somebody says, this is a layer 2 device, immediately you know that we're talking about something at the data link layer, maybe like a switch, something that can make forwarding decisions based on layer 2 information. We know that we could be talking about the MAC or the LLC sublayers of the data link layer. If somebody says, here's a layer 3 device, in my mind, I immediately think, hey, here's a router. Here's something that can make a forwarding decision based on layer 3 information. So these models, they're great to know as a foundation as we're starting to build our networking knowledge, because a lot of the protocols, a lot of the devices, as you read about them, they're going to refer back to these models. In this first part of the video course, we've covered a couple of modules. The first module was an introduction to networks. What's the purpose of a network? What are some of the components of a network? For example, switches and routers. What kind of media might we use to interconnect these network components? Maybe unshielded twisted pair, maybe fiber optics. We discussed the distinction between multi-mode and single-mode fiber optics. And we spent quite a bit of time talking about how we could categorize networks. We could categorize networks based on how they're interconnected. Is it a star? Is it a bus? Is it a ring? Or how geographically dispersed they are, such as, is this a LAN? Is this a WAN? Or we could say, is this a peer-to-peer network or a client-server network? We discussed a variety of categories of networks. Then, in our second module, we identified a couple of reference models. These reference models allow us to take a protocol, a technology, a network device, and see how it interrelates with another network device or protocol or technology. By having a standardized reference model, or in our case, we looked at a couple of models, network professionals can communicate more effectively about what they're working on. They can say, this is a layer 2 device, so we know this is something like a switch. It can make forwarding decisions maybe based on layer 2, maybe based on MAC address information. And we took a look at two different models. The ISO, the International Standards Organization, developed the OSI, the Open Systems Interconnect model, with its 7 layers. And then we had a model developed by the United States Department of Defense, and that was the DoD model, also known as the TCP/IP stack. It only had 4 layers, and a lot of people would argue that that's a better fit for most of today's networks because it's IP-centric. The OSI model was more generalized. It could encompass IP, IPX, AppleTalk, DECnet, Banyan Vines, a variety of things that would plug into that model. But the TCP/IP model was much more IP-focused. And honestly, that's probably what we're running on our networks today. Maybe IP version 4, maybe IP version 6, but it's probably an IP-centric network. And by having this simplified model, in many cases, it makes it a lot easier to categorize a network component into one of the 4 layers as opposed to one of the OSI model's 7 layers. And with these network fundamentals now under our belt, we're ready to move in to part 2. In part 2, we're going to start seeing how to configure some of these network devices that we've been talking about in theory. In this module, we've been discussing Ethernet. We began by talking about the history of Ethernet. Remember, it was developed by Xerox back in 1972, and it's come a long way since then. We talked about some of the different speeds and feeds, some of the different media that we might use to transmit Ethernet, and we spent the bulk of the module talking about basic switch operation. We talked about how a switch learns a MAC address and how a MAC address is made up. We talked about the CAM table, the content addressable memory table that stores the MAC addresses within our switch. We contrasted broadcast domains and collision domains and just got a better understanding of how a switch is going to forward a frame that it receives on one port out of a destination port. In this module, we've been considering Ethernet switches, specifically Cisco Catalyst Ethernet switches. We took a look at how to connect administratively to the switch. We could do it locally through a console cable. We could connect over the network using Telnet or Secure Shell. We preferred Secure Shell, however, because it was secure. Once we got connected and we learned our way around the switch, we learned how to number different interfaces, different ports, we started giving some show commands to glean some information about the switch. We could see things like its version, its current configuration. We also got in and did some basic configuration. We set the host name, we set the management IP address, we set things like the speed and duplex on a port. We set the default gateway, and then we got a bit more advanced. We said we've got all these ports on the front of our switch. Maybe they don't all belong to the same subnet. Maybe they should belong to different broadcast domains. And we gave a term to a broadcast domain called a VLAN, a virtual LAN, and we said that we could group ports on a switch into different VLANs. And that's great. We get broadcast domain isolation like that. In order to get from one VLAN to the other, though, we have to route. We've got to go out and we've got to touch a layer 3 device like a multi-layer switch or like a router. And if we're wanting to send traffic for all these VLANs on one switch to another switch, instead of dedicating a physical port per VLAN, we saw a much more efficient way of doing that, and that was to use a trunk. A trunk had the unique ability of sending traffic for multiple VLANs over a single physical connection. And then we made the observation that if we've got a large enterprise network with lots of switches, and all of these switches need to have basically the same set of VLANs, that's a lot of work to go to each switch and add this VLAN and name that VLAN and add another VLAN and another VLAN and make it match on all the switches in the topology. We saw an automated way of doing that. We talked about VTP, the VLAN trunking protocol. VTP allowed us to create a VLAN on one switch, and the creation of that VLAN could be advertised over a trunk link to neighboring switches. So we just have to create the VLAN once, and it gets propagated, it gets advertised throughout our infrastructure. In this module, we took a look at troubleshooting our Cisco Catalyst switches. We gave you some troubleshooting tips such as how do we isolate the problem, exactly what is going on, how do we get information, how do we get clues about the problem by looking at our interface status. What about our neighbors? We could use CDP, the Cisco Discovery Protocol, to learn about directly attached layer 2 devices. Remember CDP, it runs at layer 2. We don't even need layer 3 to be configured. We can see layer 2 adjacencies. And we also said the ports inside of our Cisco Catalyst switch, maybe a port's not working because it belongs to the wrong VLAN. We saw how to verify VLAN membership, and also when we're connecting from one switch to another switch, we commonly use a trunk, a connection that can carry traffic for multiple VLANs, and we saw how to get information about that trunk connection to make sure it's configured as we think it's configured. In this part of our video series, we've been focused on Ethernet. We took a look at the basic operations of Ethernet. We defined terms such as a broadcast domain, a collision domain. We understood how a layer 2 Ethernet switch does its job, making forwarding decisions based on destination MAC address information. Then we started to focus more specifically on the Cisco Catalyst series of Ethernet switches. We saw how to administratively connect to a Cisco Catalyst switch. We could do it locally via a console port. We could do it over the network using Telnet or Secure Shell. We saw how to get information from the switch, like its version number as an example. We saw how to do some basic configuration, setting the host name, setting the management IP address. Then we started to carve up the ports on our Cisco Catalyst switch into different VLANs, into different broadcast domains. And we said if we wanted to communicate traffic from these different VLANs to another switch, a neighboring switch, instead of dedicating a physical port per VLAN, because that doesn't scale very well, we said that we could send traffic for all of our VLANs to our neighboring switch over just one port. And that special type of port was called a trunk port. A scalability issue that we saw how to overcome was if we've got lots of switches in our Cisco Catalyst network and we have a set of VLANs that we want to exist on just about every switch, that's a lot of administrative work to go to every switch and duplicate our efforts every single time and type everything in correctly at that. So we saw a shortcut. We saw a way to automate that process a bit. Specifically, we talked about VTP, the VLAN trunking protocol. That allowed us to create a VLAN on one switch and have that new VLAN be advertised throughout our infrastructure. And finally, in this part of the video series, we talked about troubleshooting. What do we do when things just aren't working correctly down at layer 2? Well, we need to isolate the problem. We could also get a lot of information from our interface status. We saw how to leverage CDP, the Cisco Discovery Protocol, to check our neighbors. We also talked about how we could verify that a port belonged to the appropriate VLAN and that our trunks were configured correctly.